Hello, my name is Anna Cornelio. I'm a Specialist Solutions Architect with the Data and Analytics team at AWS. I love my job. I'm really fortunate to work with a wide range of customers across Australia and New Zealand on building the next generation of data platforms. I work with the largest enterprises all the way through to the smallest startups. The nature of what I do is broad and varied, but helping customers to extract value out of their data is what I'm really passionate about. Today, we're going to be talking about the evolving role of the data analyst, a role which varies greatly from organisation to organisation, but one of the most important roles in bridging the gap between IT and the business, and can be really key to extracting the value I was talking about earlier. Today, I will take you through some of the trends and new tooling in the AWS Analytics portfolio, which will help you to accelerate your time to value and provide capabilities beyond the traditional skill set of a data analyst. If you are watching this presentation today, you are likely familiar with the transformational benefits of a modern data platform. For any sizable company, this is no longer an option, but a necessity. Many organisations use data and analytics not only to gain competitive advantage, but to remain relevant in the digital era. Data and analytics platforms are driving new high business use cases, which are fundamentally transforming customer experiences. My favourite example of this is the recommendation engine from Amazon.com. When you go onto Amazon.com and place something in your cart, you will get a recommendation of other items you might like to purchase based on the buying patterns of other customers. As a personal user of Amazon.com, I use this to reduce the time I take to shop. And sometimes I find things I never thought I needed, even though my husband might disagree. I'm going to tell you a little bit more about this use case later in the session today. Another type of use case is improving business operations. This could include implementing predictive maintenance for a manufacturing organisation or optimising supply chain for retail. I was working just the other day with an organisation who wanted to optimise the route of their trucks to improve fuel consumption. This is often focused on impacting the bottom line and driving organisational efficiencies, resulting in cost reduction. Sometimes, just a small optimisation can make a really big difference to the bottom line. We also see use cases impacting the top line by enabling better and faster decision making. This is generally about driving an increase in sales, which includes examples such as supporting a dynamic pricing engine or demand planning. The last and newest type of use case is innovation. Personally, I'm finding more and more of my customers are looking at data and analytics to expand their portfolio and even to open up new revenue streams. For example, monetizing data products. In these cases, analytics is the product that customers purchase. To enable these use cases, companies will typically build a platform to support 4 types of capabilities. Depending on your maturity, you might have one or all 4 of these capabilities in your organisation today. The first is descriptive analytics. As the name suggests, this describes what has happened in your business. This might tell you things like how many widgets you sold in July 2020 or who was your top performing sales representative. Diagnostic analytics is the next phase in the evolution. Also looking backward at the company's performance, diagnostic identifies why something happened. For example, say I'm looking at my sales dashboard and I see a drop in sales. In that same dashboard, I might also be able to see low inventory for my top selling items, which could explain why sales are low. The third phase is predictive analytics, where we use data from the past to predict what might happen in the future. Think about this capability like your own crystal ball, backed of course by your data and analytics platform. This could be, as an example, a seasonal sales forecast, which predicts future sales and might be able to help with things like stock replenishment issues. And the last is prescriptive analytics, which informs what to do next. This might leverage the insight found in predictive analytics to run different scenarios and recommend the next best action, offer, or decision. The first 3 capabilities we have spoken about requires human interaction to action the insight, typically by a business person. But with prescriptive analytics, as the next step, we could also look at automatically actioning the insights as well. Now that's a pretty cool thing. Using traditional tooling, trying to mature the capabilities of your data platform can be really challenging. In many cases, enabling high-impact use cases requires a number of different skills and personas who need to prioritize and coordinate to deliver outcomes. Let's unpack this a little bit further. To achieve descriptive, diagnostic, predictive, and prescriptive analytics, you will need different personas. We might require a data engineer or a modeler to manipulate the data and transform it into a usable form. This would require ingest, cleanse, transform, and store processing of the data. We would also need a data analyst who would analyze numeric data to help answer questions and create visualizations for the business users. The data analyst would typically focus on what happened and why it happened, or to relate it to our four capabilities, the descriptive and diagnostic analytics. Like the data analyst, the data scientist also analyzes data. They are trained in scientific methods, processes, algorithms, and systems to run predictions on historical data. They look back at what has happened to help inform the next course of action. They typically work within the predictive and prescriptive set of capabilities. And then, of course, there is the business person who will bridge the gap between the insight and the decision. They are the human interaction usually required to turn an insight, like sales are low, to an action like let's run a campaign. In the past, these personas often worked in isolation, perhaps even in different teams. In fact, sometimes I see these personas dotted around different parts of an organisation. A great example is the data analyst and the data scientist, which might belong to a central function or to a specific business unit like finance or marketing. Sometimes I even see a combination of both. When it comes to delivering an end-to-end use case, the demand and priorities of these different personas can create friction and complexity. Not to mention, some organisations don't even have all these personas and may have to look at upskilling existing personnel or forgo capabilities altogether. Now, I wanted to share with you a personal story from my past which talks to this skills challenge. Almost a decade ago, I was working with a marketing manager of a retail organisation. Using inspiration from Amazon.com, the marketing manager wanted to do basket analysis to anticipate buying behaviour and build campaigns targeting frequently bought items. Having only SQL and data modelling skills and no data science background, I went on a discovery mission to see if I could make this request a reality. This was no easy task. First, we needed to stand up an R server. Luckily, we found a spare rack in the data center, and I went on a course to learn the basics of R. This was all before we chose the correct algorithm for our use case. If you're wondering, we landed on the a priori algorithm, which was famously used for the beer and nappies Walmart use case. The solution we implemented was very successful and was used by the marketing team to drive more successful campaigns and resulted in an increase in revenue. Although successful, the time and effort it took to deliver the insight was immense and not scalable across the business. It can be really challenging for someone with SQL and data modelling skills to delve into the world of data science, and vice versa. I know this firsthand. You might have also had a similar experience in the past. Luckily, the future is changing. We now have new tools and services which are designed specifically to work in the intersection of these traditional roles by abstracting the complexity of tasks performed on the data platform. In other words, these new tools are enabling the convergence of your typical personas. The data scientist is able to run data engineering tasks. The data analyst is able to run machine learning models, and the business person is able to self-service analytical tasks. And these personas are doing this not with months of upskill and setup, but in a fraction of the time it used to take. This doesn't mean that the traditional roles become any less relevant, because we all know these skills are hard to find and are becoming more and more in demand. But with more people in the organisation able to perform complex tasks, you can scale your analytics capabilities, embedding data and analytics into every role and process, and ultimately reduce your time to value. There are three trends which are enabling this change. The first is the move to cloud, perhaps an obvious one, but what we are seeing today is a drive towards agility where we can spin up new infrastructure and services and experiment at the speed of thought. When I look back at the experience I was telling you about earlier, the first thing we needed to do was provision the infrastructure. Remember that R server? Something which took months in duration and lots of preparation is now almost completely eliminated from the data to insight process. The value proposition of moving to the cloud has been proven time and time again, but for my customers, this agility is the element that really moves the needle by enabling new capabilities, particularly in the data and analytics space. If you want to run a machine learning model, you can spin up Amazon SageMaker or one of our higher order AI services and do this all in a Friday afternoon. If you like it, keep it. If you're not getting any value, shut it down and only pay for what you use. If you're interested in learning more about this topic, one of my colleagues, Praveen Kumar, is presenting another session at Summit on leveraging cloud thinking for data and analytics. I can highly recommend this talk. The second trend is no and low-code applications. The move towards digital businesses has sparked the emergence of citizen developers, which in turn has influenced the rise in low-code solutions. We are seeing more and more options for customers who are wanting a more drag and drop type of solution. And this trend has translated to data and analytics in the form of extremely simple to use tools for complex data processing like ETL, data warehousing, and more. I'm going to be showing you some of these options later in the presentation. And finally, we have augmented analytics, which is a new trend that leverages machine learning automation to augment human intelligence. Essentially, we are infusing ML into core aspects of our data processing to reduce time to insight and enable business self-service. An example of this is data discovery platforms, which use machine learning to automatically find, visualize, and narrate relevant findings without having to build models or write algorithms. Users can explore data via visualization, search, and natural language query technologies. This is a really exciting space, and I have some awesome new tools to show you later on in the presentation today. At AWS, we have built our data platform to give you the broadest and deepest portfolio of purpose-built analytics services. We know how important data and analytics is to your organization, so these services are designed to work seamlessly together to support almost any use case you have. These services are best in class, which means you never have to compromise on performance, scale, or cost. Customers I work with love the tight integration between AWS services, so as you mature your analytics capability over time, perhaps you are moving from traditional BI workloads into predictive or prescriptive analytics, you can connect to or collect data from your data stores easily. At AWS, we are innovating at a fast clip to ensure you can take advantage of these latest trends and advancements in technology. I want to show you today 3 tools in the AWS portfolio which can help you to mature your analytics platform with very little upskill. These tools operate in the intersection of our traditional data platform personas and can all be used to supercharge the role of the data analyst. These are AWS Glue Data Brew, Amazon Redshift ML, and Amazon QuickSight Q. AWS Glue Data Brew is a visual data preparation tool that makes it easy for data analysts to clean and normalize data to prepare it for analytics and machine learning. You can choose from over 250 pre-built transformations to automate data preparation tasks, all without the need to write any code. Amazon Redshift ML makes it possible for data warehouse users to create, train, and deploy machine learning models using familiar SQL commands. Redshift ML automatically discovers and tunes the best model based on training data using Amazon SageMaker Autopilot. Autopilot chooses among the best regression, binary, or multi-class classification and linear models. That's right, you don't even need to know which algorithm to choose. Amazon QuickSight Q is a machine learning powered capability that uses natural language processing to answer your business questions instantly, saving weeks of effort from BI teams having to predefine data models and dashboards. So here's the fun part. Let's have a look at these tools in action. I'm going to show you a demo today based on an FSI customer. We are going to use advanced analytics techniques to analyze customer churn. Behind the scenes, we will use Glue Data Brew to cleanse and transform the data, Redshift ML to train and run inference on our churn models, and QuickSight Q to ask the platform questions about our data. In this demo, we are looking through the eyes of the analytics team at Octank, a financial services company with a similar goal to many organisations. They want to reduce customer churn. Here is a dashboard which shows some vital metrics about customer numbers and revenue and tells a story about the state of the business. Some interesting insights. Here we can see at the start of the year that the number of customers exiting our platform was higher than the number of new customers entering. But we see from April that this situation has stabilised, and from May we have more customers entering the platform than exiting. You can also see more information about the customers who are churning. This Sankey chart shows more females than men and a higher proportion leaving from Victoria. In this heat map, we see that most of the customers leaving the platform are using only one of our financial products, despite their tenure. Up the top of the dashboard, we have some prediction metrics, which tells us how many customers are at high risk of churn. A huge 24% of our customer base are in this high risk category. But I have some other questions which are not immediately answered in this dashboard that might help me to understand better what is happening in my business. I see up the top of the dashboard that revenue is up from last month. What I would like to see are the sales trends week on week for Victoria. To do this, I can simply ask the dashboard a question. What is the weekly revenue trend for Victoria? You see here, the revenue is following a similar trend to our customer analysis. Let's try this again. Show me the count of customers by number of products. Look at the huge number of customers just using one product. You can already see in this dashboard some important information that will be useful in reducing customer churn. In fact, we are utilising some of the core capabilities of our analytics platform to help us understand what has happened, why it has happened, and what might happen next. Or in other words, descriptive analytics, diagnostic analytics, and predictive analytics. Traditionally, a data analyst would have the skills to build only part of this dashboard. But in the next 5 minutes, I'm going to show you how you can build the core elements of this dashboard, which would usually require significant effort and upskill for a data analyst. Because this dashboard has been built using QuickSight, I'm able to use the power of QuickSight Q to ask questions about my business, which are not shown on the dashboard. QuickSight also seamlessly integrates with other services in the AWS portfolio, so it doesn't matter if the data is stored in an OLTP database or a data warehouse or a data lake, the data is very easily integrated to create these impactful visualizations. We are going to start today with a simple CSV file which contains information about the customers who have exited our platform. You can see this CSV contains information about our customers, like if they have a credit card, how many services they use, their date of birth, and if they have exited the platform. We have uploaded this file and you can see here it is available in S3. Unfortunately, data is rarely ingested in a format which is immediately usable. Generally, it would require some transformation or cleansing. Before you can use this dataset, we need to clean the data. We are going to make 2 changes to the dataset today. We are going to harmonize our customer ID column to conform to the data warehouse standard, and we are going to change the date of birth column to age so that we can use this as a feature in our customer churn model. For this data cleansing, we are going to use AWS Glue Data Brew, a no-code solution for preparing our data. Here we are in the Glue Data Brew console. The first thing you do is create a project. You give your project a name, Choose your dataset. In this case, we'll pick the S3 file location where we landed our CSV file. Choose your role, and away you go. Glue Data Brew takes just a few moments to launch, so I'm going to speed up the video here. Once Glue Data Brew is launched, you can create the 2 data cleansing rules. You'll see as we create the rules today, they are added into a recipe, which can be used to run our job. The first step is the harmonization of the customer ID field. You can add leading zeros to conform to the data warehousing standard for customer ID. First, convert the field to a string. Next, add leading zeros, and then apply your changes. The second thing you are going to do is calculate age from date of birth. For this, you are going to use the dateDiff function and subtract date of birth from today. Aggregate by year, and apply your changes. Next, we'll change the data type to an integer. Now let's run this job. You can select the job name, the target S3 location for the file, and the file type. In this case, we're going to use a simple CSV, but we also have the option of Parquet and other popular formats. We choose our role and execute the job. We can check on the status of our job by going to the monitoring screen. For this, I'll just speed up the video again. The job has now executed successfully, and the output file has landed in the S3 location we specified. Next, we are going to ingest the data into Amazon Redshift, Amazon's cloud-native data warehousing service. We are going to use Redshift to process and further curate our data. This is also where we will train our customer churn model. We are connecting to Redshift using the inbuilt SQL console. Once in Redshift, the first thing we are going to do is create our table. We do this using familiar ANSI SQL. I'm going to do a quick select on my data so that you can see that it is loaded. Thanks to the new Redshift ML feature, we can create and train our model directly in Redshift without the need to launch another service or do any complex processing like turning our string values into numbers. For this use case, we are going to use Redshift ML to predict customer churn. That is, try to predict the customers which are most likely to exit based on the attributes of the customers that have left in the past. To do this, we are going to train a model to predict the exit field using the attributes we have in our dataset. Once we start training the model, we can see the status by running the show model command. Redshift immediately integrates with Amazon SageMaker behind the scenes to start training the model against different hyperparameters. As our model is training, let's have a look at what is happening behind the scenes. As you see, the job is currently running in Amazon SageMaker. We can see the different training models being run and the accuracy of each job. The job with the highest accuracy at the moment is sitting at 75%. At the end of the training process, our Redshift churn model will be trained using the algorithm and parameters with the highest accuracy, taking the heavy lifting and specialist skill out of running this model. We will wait just a moment for the process to complete. Let's go back to Redshift and check out the status of our model. You see here it is now ready for us to use. You can start using our new churn model in your Redshift queries by using the function. Here I am creating a list of customer IDs which are likely to churn in Victoria using my customer master table. We could give this list, for example, to our sales representatives or marketing team to target. We can also use this data to support our dashboards, which you've already seen in QuickSight. Now let me show you how quickly and easily you can enable QuickSight Q for your dashboard or dataset. The first thing you're going to do is create a QuickSight topic. This indexes your data in a format that Q can use to query. Going into the QuickSight console, you access Topic from the menu bar. Create a new topic. You can give it a name and a useful description. Select the data source. In this case, we are using the data source from the Churn dashboard, and then click Create. Now, for those of you out there who are very observant, you might have noticed something special about the questions I asked QuickSight Q earlier. In the first question, when I asked about the sales in Victoria, I didn't use the field value VIC like it was in the dataset, but the value Victoria. Similarly, when I asked about the number of products, I used a term that was slightly different. I did this by creating a synonym in QuickSight Q. Once our topic index is built, we can go into the dataset and create synonyms for our columns and values. For customer, sometimes we refer to them as clients or clientele. For number of products, sometimes people use no or none, so you can create different synonyms to catch these different phrases. So now, let me try this again. Show me a count of clientele by number of products. See, I have the same answer, just asked slightly differently. QuickSight Q is self-learning and gets better at answering your questions over time. By selecting the thumbs up, you have told Q that the answer was helpful. Whether your existing platform is Excel spreadsheets or a sophisticated lakehouse architecture, you will be able to use these new tools and others to help you mature your capability, increase the number of users able to run complex tasks, and reduce your time to value. I hope this session today has given you some inspiration to rethink the scope of the roles in your organisation and how they might evolve over time. I'm always amazed by the creative and impactful architectures my customers create, and I cannot wait to see what you build using this new breed of analytics tools. In the session today, we have discussed the core capabilities of a modern data platform: descriptive, diagnostic, predictive, and prescriptive analytics. We also discussed how traditional roles are converging across the data platform, which can help you to scale the analytics capability in your organisation and mature your platform. We also took a closer look at 3 AWS tools which can supercharge the tasks performed by the data analyst. If you are interested in learning more about the capabilities of the AWS platform, I can highly recommend watching the related sessions on screen delivered by my colleagues here at AWS. Today's session is only the tip of the iceberg. If you are interested to dive deeper, here are some resources that you can use. We offer free digital courses that cover a range of AWS analytics services, such as Redshift, Glue, and QuickSight, and others we haven't discussed today, like EMR and Athena. We also offer classroom trainings to learn from AWS expert instructors. We offer a number of certifications, including one on data and analytics. And finally, you could access resources such as blogs, white papers, tutorials, and technical talks on our website. Thank you so much for your time today. I really enjoyed taking you through some of the exciting new tooling for the data analyst. I'm looking forward to sharing more exciting analytics capabilities with you soon, but for now, happy building. If you've enjoyed this video, please leave feedback. See ya.